everyone. This is John Hayes. I'm the producer for this session. I would like to introduce you all to Alessio De Angelis, who will be leading the session GraphRag in Action, Revolutionizing Fraud Detection Techniques. Alessio, the floor is yours. Over to you.
Have you ever thought that the data is very similar to the piece of a jigsaw puzzle? Let's consider it. They are very unique. Every piece is unique, has its own feature, has its own color, has its own shape. At the same time, it's beautiful, but it's worthless if you keep it and take it alone. As a piece of puzzle is much better when you connect this data all together, like this. You form a greater image. You start seeing the connections between each piece of the puzzle. And the data starts becoming and taking a bigger shape. Hello, everybody. Welcome to this session. My name is Alessio De Angelis, and today we will going to talk about how to use the GraphRag for revolutionize the fraud detection pipeline. And we will see how it's important to connect the data, to not take the data as individual points, but actually make them together as a jigsaw puzzle. Let me briefly introduce myself. I am working as a senior solutions architect in the big data field in Italy, and I've been working actually with Neo4j. I think I started back in 2010 for my master thesis at university, and it was love at first sight. And I like the fact that it's always improving and is a graph database that really meets my needs, as in this one. In fact, at work, I use it a lot, especially in fraud detection use cases. Thanks to Neo4j to giving me the possibility to be here on this stage to share with you guys my experience. We were talking about frauds. Frauds are a very problem that is affecting so many different use cases. What is the fraud? Well, it can happen everywhere. It's the act of deceiving a person, organization, by lying of who you are, what you're offering. You are lying on the details of a product, of a service. You want to gain an unfair benefit or cause a loss to another party, and you want to gain advantage of several things that are against the general rule of that use case on the product, and is a very pervasive and costly problem, and it's actually very deep because there are fraud losses, but on below of them there are very small little components that you need to take into account. And global fraud losses are actually increasing over by year. And the traditional fraud detection methods are struggling a lot to keep up with sophisticated techniques, and really impacts various industries: finance, e-commerce, insurance, healthcare. And there are, yes, as well, financial losses, but even the reputational damage, and a lot of time regulatory penalties. And there are several categories of fraud, and sometimes the individual is acting by himself just for sometimes to act as another person, or a lot of times there are more individuals that group together and in order to make loss to other persons' identities or personal details. So there are several categories of fraud. However, traditional fraud detection platforms are starting falling short They are for sure established method, and their implementation is actually simple. At the same time, they have a lot of cons. Sometimes they are rule based, so they are based on rigid rules. They are difficult to maintain, easily to bypass, or they can miss patterns. A lot of time they lack the ability to reason and understand the underlying connection between entities. And a lot of times as well, the data is treated as data silos. Information is fragmented, hindering and eliciting a view of a potential fraud. So what can we do about it? Wouldn't it be fantastic to have a tool that naturally models the relationship among the data, that naturally knows, okay, these two pieces must be together, and they create they are together because they are connected for some reason, and then you go in that puzzle, you connect the other dots. That would be really great. And I was thinking back now a lot of years ago, is there any software, any tool, any database that naturally can help me modeling those relationships? And of course the answer is yes. With Neo4j, we are able to connect the dots in a natural way. In fact, fraudsters, a lot of times, they are operating in rings. And a pattern, if like what transaction, you will say, okay, the transaction is fine. Someone is transferring money to another one. But what happens when these patterns are repeated, when there are sort of anomalies among those transactions? In that case, you see that the bigger image starts showing. Like a lot of times we have database where the users has an email, as a phone, as a serial number. But what happens that when you realize that actually other three users share the same email, share the same phone number, and they are operating in a very similar way? Well, that with a graph database is very easy to discover. And we can evolve in this way our fraud detection apps. Okay, in my case, we realized a lot of applications based on Neo4j, graph databases, graph data science. But we were struggling a lot in making sometimes the user make the fully potential. A lot of time, the final user of application that doesn't know about Cypher, that doesn't know a lot, or sometimes even they don't want to learn a new language. And so I was thinking, how can I make the life of the customers easier in discovering fraud detection? Do they actually need to know about all Cypher, or there can be an easier way for them to help them uncovering and discovering their frauds? Well, yes, thanks to GraphRag, we added a more layer for creating an intelligent fraud detection. So we are thanks to the GraphRag, we can create a retrieval system that is robust and that harness the contextual richness of graph-based data and takes the relationships and the context among data in a natural way. So we are like using both the power of graph databases in modeling data and the power of retrieval augmented generation for discovering the frauds. What is an example workflow of of a GraphRag in the context of fraud detection? Well, you will see what you will see today is actually actually can be replicated in several contexts, and this is what I like a lot of this of Neo4j graph database. A pipeline usually starts from a user query, because we are a lot of times we are providing our customer with a natural language form where they can type in their chat, they can type in the question, and after the output is modeled as in their web application. Doing so, the user starts querying and asking about some suspicious transaction. Then there is the graph retrieval part, where the system retrieves the data in the in their database. And then there is the contextualization, thanks to the GraphRag. The retrieved information is used to create a contextual understanding of the transaction. And then the LLM explains the potential fraud to the user, so that the analyst receives the clear explanation of what is happening inside. So they can really have the meaning of their data in a much easier way, and it really speeds up even for me when I go to a customer and ask for what they need. It's much easier for them to tell them, okay, you have a chat that you can use to type in to your data, instead of telling them, okay, you have to learn Cypher, you have to learn this. Well, you realize that it's actually much easier doing it and doing so obtaining a lot of business value out of it. And as I was saying at the beginning, the frauds are happening in a very in a lot of use cases. Something that is really tricky is even anti-money laundering. It's something that the money that are bad money obtained in a malicious way, they are then converted into positive money, and that is not easy at all to discover. But thanks to these technologies, it is much easier to see when the one user would be would give to them. And there are other causes like e-commerce fraud, credit card fraud, when someone is sort of stealing your identities in order to make it feasible, and in order to act as another person. So now I've been talking a lot of the introduction, yes, and then feel free to ask your question in the session, and I will try to do my best to answer it in the at the end of the presentation. And here now we will see the demo. Unfortunately, I couldn't show you all the what I actually created in production, but I think probably it's better in this way, because we will try to create together a GraphRag application that then you can try to replicate over your data. As dataset, we are using one of the most famous financial dataset that we have, that are offered by Neo4j for free. That is the PaySim fraud detection dataset. So that after you can even try to replicate everything on your own. And in this way, we don't violate any privacy issue, and the data is all we will show is everything is synthetic. So there is if you find your name in that data set, don't worry, it's just synthetic and anonymous. So now I will switch the screen. I hope to do it in an easy way. So screen, and then let's go to my IntelliJ. Okay. Okay, here you are. Shared. So meanwhile, you take it. Okay, yes. Now it's shown. You have here. This is a simple GraphRag application. And I wanted to show you actually only this one, but then I discovered that Neo4j offered a new product for creating agents on Neo4j Aura. I discovered last week. So I would say, okay, for Nodes 2025, I will take this challenge. Let's create an agent on Aura as well. So, but before, let's start with this one. So here we see that we are creating a connection to the graph database. And then we want to instantiate our LLM. Well, I chose to Vertex AI as LLM provider, but you can use a lot of different different LLM providers like Olama as well for Yoga Machine, OpenAI, Anthropic as well. Yeah, here we are in particular, we are telling to our LLM, please take the temperature to 0. This means that I don't want you to be creative. Please stick to the data as much as you can, because especially in a fraud detection use case, it's better to be real, because when you say to someone, oh, okay, you are a fraudster, it is never good. So it's better to be cautious and not be creative. Of course, all of these instruments never tell you the exactly 100% that that guy is acting in a suspicious way, but they are, especially in my case, they are instruments that the analysts can use in their normal pipeline to be faster and to have a starting point in understanding better what they have in their data in order to go deeper. And here in the to the LLM, we are providing a schema as well in order to help him to know what is under and creating a much better query. In this case, I'm using the text to cipher retriever. Because, as I said before, I prefer that the query is not perfect, doesn't return any result, instead of having a result that is not good, and giving the fact that could be a potential fraudster to someone that actually isn't. So after telling here all the schema, you have to provide some example as well to your retriever and to your GraphRag in order to help him understand better and to create queries that are trained, and giving some hints as well. And user input and query. So here you see that the query is actually a cipher query we use as an example. Then there is the retriever, as we said, we are using text to cipher retriever. Then you have the GraphRag, and after you click here on search to ask the retriever, and then the rag. There is a little bit difference between two of them, because the retriever actually retrieves the query, the cipher query, and the result of the cipher query. And that is very useful when you want to add your cipher query to your application. At the same time, when you want to add more descriptive information, you have to use GraphRag search in order to answer in a natural language way. Now, for the sake of brevity, I will show you already the response I did before the presentation, because I'm going very, very close to the end of the time. So here you will see the user is asking, can you give me a couple of clients that share the same email and phone number with other clients? And here the retriever is generating a query that actually says, yes, there are some clients that are sharing email, they are sharing the phone number, and they are they maybe the same person? And here after the GraphRag search adds a lot of natural language reasoning. And here it says, yes, here are a couple of clients that share the same email and phone number with other clients. And here they are all the couples that we found. And then another query that is similar to that one, but a little bit trigger, because here we don't say what is for me similar. I will let him reason about what intends to be similar. So here I'm asking, which are the clients that are most similar each other? The retriever generates the query that is actually very similar to the other one, and then answers you back. The clients that are most similar to each other are those who share the same email address and phone number across multiple records. And then here it shows all the couple or groups of identities that are very similar and strong together. And then you can make more analysis afterwards. Then the third one, actually, no, the fourth one, okay, the third one is very similar to the other one. You have two starting points, Christian, Irwin, and Lorenzo, that maybe you, from other analysis you have done in the past, you think that they are very similar. Is it true in this data set as well? And yes, it answers you back that after creating the query, Christian, Irwin, and Lorenzo are very similar because they share the phone number. Another query that is quite similar but a little bit different is this one. Are there clients that transact with fraudsters clients? Here it tries to create this query and actually realizes that yes, there are clients as Zoe Burgess or Alexander Wynn that transact with fraudster clients, and here is the answer. And you see that it's quite easy thanks to this GraphRag library to create your own GraphRag application. And it's very easy to create an agent based on Neo4j Aura, and I will show you in a few moments. And let's share this screen and this one, yes. So here I am in my Neo4j Aura account, and here I created a new agent called fraud detection agent. As you see, is a friendly neighborhood fraud detective powered by Neo4j. Connect the dots literally to find the fraudsters even before they know they have been spotted. Elementary, my dear user. And this is what I actually wanted, and I wanted to provide to my customer. A tool that they can use for making questions in natural language without knowing any cipher, and then that answers them back in a natural language way. And this is also in my idea. Let's check what is made inside. Here is the description we saw before, and then here I'm giving a prompt to the agent here and saying you're a fraud detection and investigation agent, a specialized AI assistant for financial fraud analysis using a knowledge graph in Neo4j. Your knowledge is based on the pacing dataset, which simulates real-world money transfer network. And then you write yes all your prompt instructions. Okay, yes, I still have a few minutes, so I can go over it. You have access to a comprehensive knowledge graph containing synthetic, mobile, money transaction data, customer personal identifiable information, and the relationships between them. You can query this graph using tools and Cypher to help you get answers. You can support further investigation teams by detecting first-party fraudsters, uncovering third-party fraud, identifying suspicious networks, tracing illicit funds. So you are giving, you're instructing your agent to what must behave. Here, then you select the target instance. GraphRag in action is my instance of my graph database. Here I say that it's internal, so it's an agent that I can use only by myself. And then here you can add a tool to your agent in order to know better what to do when the client is writing several kind of questions. And here you have several tools you can add right now: Cipher template, text to Cipher, similarity search. Here, for instance, I created this tool that is a tool for system-wide fraud detection questions. The description is: use this tool to answer free-form questions that involve aggregation of clients, transaction times, merchants, shared identifiers, and potential fraudsters. And that is used a lot when the agent doesn't know how to answer to the question. So it will do its best by creating a text to cipher query. And then here there is similarity search, and at the end there is the cipher template. You can even provide the template as we did before in the example. You can instruct your agent to be more precise on what to obtain, especially if it's a complex query, or if there is a particular use case you want really to address. And you can add parameters as well. So for instance, with this tool, you want the transaction between client and potential fraudsters. Use this tool when user asks if a specific client had a transaction with any potential fraudster. And here I write the Cipher query that can help the agent to understand and to answer the question. And for the sake of brevity as well, I will show you the result, because sometimes it can take some minutes when the query is a little bit complex. And okay, share the screen. I wrote so now a few minutes, and then it will run. Okay, demo time. Okay, let's see the next one. Here you can see the final the answers of this agent. Can you give a couple of clients that share the same email and phone number with other clients? It reasons, and after it says yes, here are a couple of clients that share the same email and phone number with other clients: Grayson Palmer and Simon Jacobs, Joan Trillo and Jack Finch. And then I ask a similar question: are there any similar clients because they share email and phone? It reasons, and after the answers back, yes, there are several clients who share the same email and phone number with other clients. This could indicate potential fraud or shared accounts. And here are all the examples that are retrieved directly by the graph. Of course, this is still an experimental. I really hope that from experimental it becomes a real production use case, so that I can have even more fun with creating agent in this with Neo4j. And so to sum up, we see that having an instrument that can help you connect the dots and connect the pieces of your puzzle is always good. And what I want you to share with you today is that using the best tool for your needs is the best choice you can make for your use cases, even if you have a hard use case as this one of fraud detection. And now I saw that you wrote some question. I will I will go through them. And Anuk asked me, hi, would this work efficiently on a database with approximately 64 million nodes and 1100 million relationships? Well, at least I speak of my experience. I have been using in production graphs that are even a billion of nodes, and they are with the right infrastructure, they are working well. Unfortunately, I have not experienced it yet with very large graph, but I would say that it's feasible because what it creates is just understanding your context, and then it translate it into a Cypher query. So then if you have a Neo4j graph database architecture that is feasible enough for your data, I would say yes. Yes, I can share the demo notebook with you. It's actually a Python script, but if you contact me privately, I will for sure share with you, and I will be more happy to share this knowledge that I learned by working on this scenario. For Graph Academy course, I'm not the right person to answer, but I think that there are in the academy there are some projects and some courses that are being created. So I would say yes, but I'm not the right person to to have to tell you. Can we create AI agents? Mohammed asked me, can we create AI agents that keep analyzing data as it keeps flowing to flag suspicious transaction and create alerts? Yeah, I would say if you add it in a bigger agent application, well, here we saw a very simple use case just to let you see how can you use your GraphRag and can you see it in action. But actually, I would say yes. Not yet, not yet. Okay, I already answered it. Can you share the demo link? Yes, for sure. Write me on on uh, uh, on LinkedIn. I put it LinkedIn, but well, I can give you even my personal email. I will write it here in this chat so that after we can keep chatting even at the end of the presentation. The name of the demo dataset is I took it from financial. I think it's called fraud detection. You find it in the use cases, official use cases provided by Neo4j, and I think there is as well one sandbox where that can let you experiment in 3 days in this use case. And this dataset is actually taken from a Kaggle dataset that is called PaySim. Okay, there are not any more questions. I hope to have answered to all of them. But anyways, feel free to connect as pieces of a puzzle at the end of this notes 2025. Thanks again, Neo4j, to letting me to have this